Q&A. You ready? All right, let's go. I'll give you a, ooh, give you a title here. If you can't read my writing, tell me, because sometimes I get real excited and start writing fast. If you need me to slow down, please don't be afraid to speak up, because I get excited, go fast, write fast, and leave you in the dust if you don't say something sometimes. So I don't ever mind stopping or going back. So graphing quadratics, just like when we graph lines. If you think back to Algebra 1 when you graph lines, and you probably graphed these as well, or at least you started them or introduced them, there's different forms that we can be in whenever we graph, right? I guess before we, not so spastic, I'm sorry. Before we graph quadratics, you should tell me what a quadratic is. What does this mean? Okay, it's got a squared in it. You're exactly right. It's got a power of 2 on the x. So a general form of quadratics looks something like this. Now, A, B, and C, we plug in numbers for those, right? So those aren't A, B, and C in the equation. We put values in. So maybe 2x squared plus 3x minus 5. But there's numbers in here. Have you all seen this before at some point, sometime? No? If you haven't, that's okay. All right, so the power of 2 here on our x is what clues us in that it's a quadratic, okay? You probably worked a whole lot with linear when you were in Algebra 1. Things that look like, well, you called it mx plus b or ax plus b. Kind of the same thing. These are numbers or coefficients. We plug things in there for those values. But it's linear. It's got the biggest exponent here on x is that 1. Now we've increased that to a 2, and that's what makes it a quadratic. Does that make sense? Quad usually means 4. That can get confusing sometimes, but it's really referencing the 2. You okay? All right. When you graph a linear equation, you obviously get a line, but what happens if you graph a quadratic equation? Do you know what you get? Do you know what it looks like? I might have said it. A parabola. That's exactly right. You get a parabola. What's a parabola look like? It looks like a U, or it could be flipped upside down. So it looks something like this, or maybe something like this. And just like lines, we can do all sorts of manipulations with it. We can make it really wide. We can make it really skinny. We can shrink it, stretch it, do all kinds of stuff. But in general, that's what a parabola looks like. So that's what we're going to be graphing today. Now, this is what we call standard form. I like to go back and relate to things that I know that you know. So if I think back to linear equations, remember how you had different forms of linear equations? You had slope-intercept form. Yesterday, y'all said y'all hadn't seen it before, but I think this was this class that I was trying to talk about point-slope form. But there's different forms of lines. There's a standard form, a slope-intercept, and a point-slope form. And all of them will give you the same line graph. You can just write them different ways. You guys remember that? Know what I'm talking about? Y'all got to at least nod your head or something. Great, dang. Okay. There's 3 forms of quadratics we're going to work with. There is standard form, intercept form, and vertex form. We're going to graph all 3, but today we're only going to look at standard form. It's the hardest to graph in my opinion, but we'll get there nonetheless. So let's talk about what is special about parabolas before we start graphing. Actually, let's look at this. Told you this is standard form of a quadratic. Yes? What if one of these is missing? In other words, what if I have x squared plus 3? Is that still a quadratic? Yeah, it's still got the power of 2 on the x. What would a be here? 1. Very good. It's 1. It doesn't look like it's there, but remember, everything has this imaginary 1 that sits in front of it, right, if you don't see anything. Oh, 0. It's not there. So if it's missing altogether, it's a 0, and that's okay. How about C? 3. What is C called, by the way? The constant. Why is it called a constant? Stays the same. It has a constant value. It doesn't have a variable hooked to it, so it doesn't vary. It stays the same. It's a constant. Everybody okay? All right. So if it's missing altogether, it's 0. If there's just no coefficient in front, it's got a coefficient of 1. Let's look at a parabola itself first, and then I'll come back to that. Here's my nice, lovely parabola. Tell me some things you notice about that parabola. It doesn't have endpoints. It goes on forever, and both ends go in the same direction, right? They're both going up. Now, I could flip it around, and they could both go down. You're welcome. What else do you notice? Think about geometry-wise. Anything? It starts with an S. That's what I'm trying to do. It's symmetric. You see that? Both sides are the same. In fact, I could draw a line of symmetry down the middle. And I'm actually going to call that the axis of symmetry. And both sides are exactly the same on either side. This axis of symmetry goes through a very, very, very important part. And it is this point right here at the very bottom. By the way, there's breakfast over here. If you'll you may know what that very bottom point there is called? The vertex. So y'all have seen this before. The way this parabola sits, that vertex would be a minimum. And it's a minimum because it's the very lowest point there on that parabola. Does that make sense? Yes, thank you. Thank you, thank you, thank you, thank you. All right, let's go back to that equation for just a second. Let's look at a few things and talk about what happens, and then we'll jump into graphing. So I'm back to the standard form equation. And I'm going to tell you what these values do and what happens here as each of these values change. I think we'll start with the C, that constant on the end. The C will always be my y-intercept, where it crosses the y-axis. The reason for that is that every y-intercept, or at the y-intercept, I can find that by plugging in a 0 for x, yeah? And if I put in 0 here, well, a times 0, doesn't matter what a is, anything times 0 is 0. And then here I put in a 0, I get 0. So those would cancel out, it'd only leave me with the c. So that's why that's always the y-intercept. It's always where it crosses the y-axis. Now the a in front probably does the most to the equation. And so it does two things. The first thing I look at, if I write it this way, do y'all know what that means? If I say a is greater than 0, what does that mean? More than 0. Give me another way to say more than 0. Positive. That's what I'm looking for. Positive. If a is a positive number, that means my parabola opens up. It's a happy parabola. But if a is less than 0, so now what am I talking about? Negative, right? So if a is smaller than 0 or a is negative, well, that tells me that my parabola opens down. So it's a down parabola. You okay? All right. Now, I told you A tells me two things. That's thing one. It tells me if my parabola goes up. Remember, because both ends go the same way, right? So if it goes up or if it goes down. The other thing that it tells me is it tells me about the width of the parabola. Okay? So if the parabola, if the absolute value of A, I'm going to start with 1. If the absolute value of A is 1, that's what we call an average parabola. And we'll talk about some parent graphs and that kind of stuff soon. But that's just a normal average width, okay? It's going to be what we compare everything to is a 1. Now, as this absolute value of A gets bigger, 2, 3, 4, 5, 10, 20, 50, whatever it is, the bigger A gets, the more narrow the graph becomes. So I'd have a real skinny little parabola. And that seems the opposite of what would happen, but the bigger A gets, the more it really shrinks in that graph. So then what do you think happens as a, and I'm saying absolute value because positive and negative only tell me up or down. They don't have anything to do with the width whatsoever. What do you think happens as A gets smaller? It gets wider. I cannot take that heat today. I'm about to die. All right, so let me give you a couple equations, and I want us to look at them together and see if we can do some analysis here to see what we kind of think it might look like without actually graphing it, and then we'll get into the actual graphing part. Tell me first, is that a quadratic? Yep, why? The x squared, power of 2 on the x. Exactly, good job. Does this parabola, what's the y-intercept on this parabola? -5. Does this parabola open up or down? Why? It's positive, exactly. Would this parabola be skinny, wide, or average? Wide. Why wide? It's less than 1, right? And in fact, and I should have said this before, I'll put wide. We talked about the absolute value of A getting smaller. The only way for A to get smaller but not be negative is when I'm looking at fractions, right? I'm talking about a half, a third, a fourth. Fractions less than 1, I should say. Be very careful because you could have a fraction bigger than 1, right? It's top heavy. Let's look at one more. Parabola or not? Yeah, it's a parabola. It's got the x squared. What's the y-intercept on this one? 0. There's no c there, right? Everybody see that? Up or down? Down, because that a is negative. Skinny, wide, or average? Why? It's bigger than 1. 5/3 is one of those top-heavy fractions. It's bigger than 1, right? That's actually 1 2/3. So I'm actually skinnier than average. No? The negative doesn't matter because remember I'm looking at the absolute value of A. Good question though, because everybody gets caught up on that. Y'all okay? Everybody's okay before I throw something else at you. All right. When we talked about parabolas, I told you there was a most important part. What was that most important part called? The vertex. But I haven't told you anything about finding them. We found a lot of things about these parabolas, but we haven't actually talked about the vertex. So I'm going to give you a little equation. I'm going to go back to this original remember, everything we're doing today is standard form. And I'm going to find the vertex in standard form. Here's how I do it. I'm first going to find, remember, everything on a graph has 2 parts, right? It's got an X and a Y. Y'all okay with that? So to find the X part first, I'm going to give you a little equation, and this is something you just have to remember. It's opposite B over 2A. That's the X part of the vertex. And not only is that the X part of the vertex, but because that axis of symmetry runs straight through the vertex, this is also the equation for the axis of symmetry. So now, let's say you're graphing a line, and I give you an X part. How do you find the corresponding Y that goes with that X? What do? Put it in the equation, right? Because I need an X and a Y, so think about it like this, like a T-chart maybe that you did before. You plug it back in. So to find the Y, I plug into my original equation. So let's practice finding a few. I'm actually going to backtrack to the two that we just did and find the vertex on those two, and then I'm going to do an example start to finish with. All right, backwards just a little bit. Look at this one. 1/2 x squared plus 3x minus 5. Find the vertex. This one might be awful to find the vertex. No, it won't be too bad. Find the vertex. We'll do this one together, then I'll let you do that. So I'm going to do x equals opposite b over 2a, right? What was my b here? 3. What if it had started out as a negative b? Be positive. That's why I keep saying opposite, even though I put a negative sign. All right, so I've got here, my x is going to be negative 3 over 2, what is a? 1/2. So it would become 1 in the denominator. So the x part of the vertex, as well as the axis of symmetry, is negative 3. That's only half the problem, though, right? The other half is the y part that I need. So how am I going to find the y part that goes with that x equals 3? Negative 3. I'm going to plug it in. That's exactly right. So I'm going to say y equals, does not look like a y, 1/2 negative 3 squared plus 3 times negative 3. I'm plugging it in for every x that I see way back up here in my original equation. And this is where you are more than welcome to use your calculator. If you don't have it just yet, that's okay. Negative 3 squared is 9. 9 times 1/2 is 9 over 2. Minus 9 minus 5. I would definitely do this on my calculator. Let's see. Y'all know how to use your calculator for fractions and stuff? You've had teachers teach you that before, I think. 9 divided by 2 minus 9 minus 5. Negative 9.5. Is that what y'all got? That's what I got. So that means, tell me where my vertex is. Negative 3, negative 9.5. That is my vertex. Does that make sense to you? All right, good deal. Here's what we're going to do is we grab, if y'all need a little brain break or stretch break in between me, let me know, because I'll just keep right on going. Here's what we're going to do. We're going to find and plot the vertex. Okay, we're going to let that be our first step, and I'm going to run through this with you. But then we're going to find 2 points, one on either side of the vertex, so that then we can connect our nice parabola together. Okay, there's going to be 3 points we need to find. Y'all need a break in between? Y'all okay? Okay? Okay. You need a snack or a juice or stand up and stretch? Y'all okay? Y'all are looking kind of... This is a long lesson, it is. I don't like to stand up here forever teaching you. All right, let's do I'm going to do you a little chart. How to graph and things. I'm going to do the steps, and then I'm going to run an example right alongside. I'll wait on y'all to get set up and ready. Y'all tell me when you're good. Ready, Freddie? All right, let's do it. First things first, let's lay out our A, B, and our C. I think that'll make things easier. So I'm going to say first, identify A, B, and C. So in our equation, what is A? -1. That's exactly right. What is B? -2. And what is C? 7. What's special about 7? Okay, what else? The y-intercept. So maybe make a note here. This is my y-intercept. Tell me before we graph this what you know about the graph before we actually do it. It opens down because of the negative. What else? It's an average width. It's not going to be skinny nor wide. It's going to be average. Good job, y'all. All right. Nothing to it but to do it. Let's find the vertex. We're going to find the vertex exactly the way we found the vertex before. And that was we're going to do opposite B over 2A. And then we're going to plug in to find y. So that I have an x and a y for my vertex. If you have A, B, and C listed out right here, it makes things a lot easier to go through and find that vertex and plug in that formula. So I'm going to do x equals, well, the opposite of B would be what? 2. And then 2 times A, what's A? -1. So x equals -1. Remember, this is also my what? Starts with an A. Axis of symmetry. Very good. Which means, and I'm just going to come over here. I'll go back in just a second. That means whatever else is happening with my parabola at -1, I know this is where that axis of symmetry is coming through. All right. I haven't finished because I've only found half of the vertex. How do I find the other half? Plug it in. That's exactly right. Where am I plugging in? That's everyone's question. That's always every x in the original equation. Be careful of signs. Be careful when you're plugging in a negative number because, yes, a negative number is squared. It's a positive number, but because this negative sits outside, it's going to force everything to be negative all the time. This is different than this. This is always negative. This is always positive. You see the difference? Order of operations say I have to do exponents first unless there's parentheses in there. So this one I would square the number and then do negative. This one I would do the negative and then square. Okay? So for this, whatever I get, it's going to be negative in the end. So you Very, very, very careful with that. So plug in, y'all plug in, I'll plug in at the same time. We'll see if we get the same thing. Oh, the dirt. So what y'all got? 8. So the vertex here is -1, 8. Everybody okay on that? So I'm just going to come over to my graph on the side. Remember, we're doing all this so that we can graph, and I told you this is the hardest form to graph in. It's the one that takes the most work, the most thought when it's in standard form, but it's also the most common way we see quadratics. So I'm going to come over here and I'm going to plot the point -1, 8. 1, 2, 3, 4, 5, 6, 7, 8. Mine is not to scale. It doesn't have to be perfect. And I'm just going to put a point here. This is my vertex. I always like to mark it and label it. You certainly don't have to, but you don't want to start getting confused with which point's the vertex, which point's the other, and what it is. So I always put my axis of symmetry on there dashed, and then I'll just go up there and put my little vertex on there wherever it goes. All right, y'all ready for the new stuff with the graphing? We've practiced that. We haven't practiced the first part. How many points did I tell you needed to graph a parabola? 3, right? I need the vertex, and then I need 1 on either side of the vertex. So for the first one that goes on the side of the vertex, how can I find a point on a graph? What do you do? Think back to even lines. If you needed another point and you didn't have like a slope to use. Any ideas? You just need an X. That's all you need. That's exactly right. All you need is an X. I'm going to call this an easy point here. My easy point could be any X that I choose. And then plug in. Or there's a very easy point that sits in my equation itself that I don't even have to do any work to get. Can you think of what that is? What is the 7? The y-intercept. It's always there. There's going to be one exception to that rule, and that is, what if your vertex sits at the y-intercept? Then I'd have to choose another one, and I'd have to go through all the plug-in stuff. But if you can use your y-intercept, why the heck not, right? Because then I don't have to do any work. So if I look over at my example, for my easy point, I'm going to use the point 0, 7 because that's my y-intercept. And I'm going to do an example with you after this where you can't use y-intercept and you actually have to pick one and show you what happens here. So on my graph, what does that look like? Well, here's my vertex, my y-intercept, there it is, 0, 7. Does that make sense? All right. Tell me what else you told me that you know about a parabola geometric-wise. It's symmetric. What does that mean? The other point would be right across. If you think back to geometry when you reflected points, if that was a mirror that sat right there and this point was here, all you'd have to do is count over to the mirror and back over here to find where it reflects over on the other side. So this is my favorite step. I call this step reflect and connect. Reflect that easy point over the axis of symmetry and just connect. So if I come over here, that's a terrible reflection because it's off. Reflect, and then I connect. Now be very careful when you connect. This does not come to a V. It's not an absolute value. It's a nice curve. So make sure you curve it when you do it. but it curves and it's slowly inching out either direction here whenever you, and there's my parabola. A lot of teachers will make you find a lot more points than that, but I think 3 is quite sufficient, especially in standard form where it can get quite I'm giving you right now. These are just, I used to and I have some resources that I typed up here. But it's just some notes. It's what you've already written down, what you already have in your notes on the front on graphing in standard form. The steps there, they might be a little bit different than the way we went through. I have 6 here. We didn't do 6. We did what, 3 or 4? But then the things to keep in mind, those are those little things we talked about at the end. And it's always a good thing to go back and check, because remember in the beginning we said it should be an average width, and it is. It should open down, and it does. It should have a y-intercept of 7, and it does. So those are good checks to see, hey, did I graph it right? I do have a hole punch. Okay. Y'all want me to pass the hole punch around? Well, you're welcome to just rip the hole. I forgot to. Anyway, if you flip over the back, there's the example that we just did together in nice, neat, typed up form for you. And we're going to do that last example together as well, because that's one of the ones that I was telling you about that didn't have, you couldn't use the y-intercept. So I know that some of y'all are going, you made us write all that down. I'm a firm believer in writing it helps you remember it. So it always helps to write it down. Plus, you'll think of things and you'll jot down to help you remember, and then you go, oh, yeah, I remember how to do this now. So, and I don't have notes for everything typed up, just some of the harder concepts. All right, so let's do example number 2 on here. Y equals 1/2 x squared plus 2x. Tell me what you know before you do it. A is 1/2. B is, and C is. Tell me what else you know. I think somebody said it, but I'm not sure. It opens up because it's positive. Skinny wide average. Wide because it's less than 1. Everybody okay? Y-intercept? 0. 0 because C is not there, right? All right, so that might give me a little bit of problems later on, but we'll go ahead and jump into graphing this the way it is. All right, first things first, my first step is to label A, B, and C. And I have. What's your second step? Find the vertex. How do I find the vertex? That's right. Opposite B over 2A, and since I've listed A, B, and C out, that makes it a lot easier to plug in, right? So I have -2 over 2 times 1/2. This looks very similar to one we did just a minute ago. What do you get? -2 over 1, which is -2. Exactly right. -2 is the x part of my vertex, as well as the axis of symmetry. I always go ahead and put that on here. No, this one's not going to have, this is not going to do what I want. Okay. This one does not have the vertex of 0. I don't know what I was thinking. I need to do one that's missing a B. I'll do it in a minute. I'll do one. All right. Plug in for Y. I got 6. What'd y'all get? Huh? Y'all are right. I'm wrong. Thank you. I did that on purpose to see if you're paying attention. No, not really. That's a story. I messed up. -2, -2. That's your vertex, yes? Let's do this since the vertex doesn't. I could use the y-intercept here. Do we all agree? What if I choose not to? What if I want to find a point? Let's say I couldn't use the y-intercept for some reason. Maybe the y-intercept is 37 and I can't use it, or for whatever reason, I just don't want to use the y-intercept. So I want to pick an easy point. I do want to stick close to the vertex because think about how those parabolas do. They start out going upright and then really quick they shoot up fast. So I want to stick close. Give me an x that would stick close to the vertex, but not be the vertex. -1. I think that's a great choice to pick. Maybe I pick -1 for my easy point. Then I'm back to what I had to do with the vertex where I'm plugging it back in to see what my y is. So here y equals 1/2 -1 squared plus 2 -1, which would be -1.5. And I could use that. I could go, okay, -1, -1.5. Reflect over 1 over 1 and connect. And that would be A-okay. This is not at all the way it should look. There we go. Had I used the y-intercept instead, I would have put this point here, and I would have reflected over by counting 1, 2, 1, 2, and I'd have the same points. So just like a line, you know, any 2 points make a line, you can use any point you want and then just connect them. It doesn't matter where on here I go, as long as I find a legitimate point and then I reflect it. Does that make sense? Yes, this makes no. Okay, I don't want to bore y'all to tears. I've been up for 38 minutes talking about graphing in one of a really long time to be talking about a lesson. Do you want me to do another one, or do you want to start on your work? Start on your work. Okay. If you need me, I am here. I'll stay up here the whole time.